So we have gone over how to solve inequalities. We have gone over how to solve absolute value equations. We are now going to put the two concepts together. And we have two different kinds of absolute value inequalities. And they have two different types of answers. We have absolute value inequalities that are less than or equal to, which are these two symbols here, or when they are greater than or equal to, which are these two symbols here. So in this video, we're going to go over the less than or equal to ones. And so we're told to solve the absolute value inequality, express our answer only in interval notation, so we don't need set notation this time, and then graph the solution set. So I have this equation here. We have the absolute value of x is less than 3. Okay. So when I have this equation here, and again, this is like the most basic equation we can get, the absolute value of x is less than 3. What this is stating is that x must be less than 3 units away from 0. So when I have my 0 here, I could go 3 units over here. And that should be positive. And I can go 3 units in the negative direction. But it's got to be less than 3 units away. So we're talking about this portion right here. Everywhere that is highlighted is less than 3 units away from 0. So in interval notation, this looks exactly the way it looks. We've got parentheses, -3, 2, 3. And for the record, these have parentheses because it's not less than or equal to. If it was less than or equal to, it'd look the exact same, but with brackets on both sides. And then my inequality is going to look like -3 is less than x, which is less than 3. So there's my interval notation and what my inequality looks like. So let's use this basic example here and apply it to these bottom two. Excuse me. Once I have this absolute value by itself, and this has to be positive, I am then going to take this, and half of this equation is going to be x is less than 3, which is exactly what this looks like without the bars. And then we'll have less than its negative or its opposite number here. So if I apply that same thing here to b, our absolute value is isolated. We have a positive over here, so we can proceed. So half of this is going to be x plus 5 is less than or equal to 17. And then over here, we're going to have another less than or equal to, and now instead of positive 17, it's negative 17. So I've set up my compound inequality. So let's solve. We'll subtract 5 from all 3 portions. I get -22 is less than or equal to x, which is less than or equal to 12. I need to express my answer in interval notation as well as graph. So graphing, we have -22 and we have 12. They both are less than or equal to, which means they both get brackets. And we're talking about everything here in the middle. So in interval notation, it looks like this: bracket -22 to 12 bracket. Okay, before I can set up my compound inequality, you've got to get this absolute value portion isolated. And we'll do that by subtracting 3 over. So I've got the absolute value of 2x plus 5 is less than 7. And I probably should have noted it on this one, but we are using this method here because we have a less than or equal to sign right here. So now that I have the absolute value portion isolated and I can see that this is a less than sign, I know I need to set up a compound inequality. So we will have 2x plus 5 is less than 7. So it looks just like this without the bars. We'll have another less than over here, and now we'll have its opposite, which is -7. So let's subtract 5 from all 3 portions. You get -12 is less than 2x, which is less than 2. And then divide all 3 sections by 2. You get -6 is less than x, which is less than 1. So my graph, we've got -6 and we've got 1. These are just less than, and so we have parentheses and then everything in between. And then my interval notation looks just like this. So we've got parentheses, -6, 1, parentheses. So when you have a less than symbol or less than or equal to, once you get that absolute value isolated, set up a compound inequality with basically what you have here as your first portion, another less than symbol, and then the opposite number over here. And when you graph, you'll have a graph that kind of includes or traps, if you will, your solution set.